Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a hexagonal pyramid of base edge 30 mm and axial height has been provided to us as 75 mm. Now this hexagonal pyramid, it is resting on its base onto the horizontal plane with one of the edges of the base parallel to the vertical plane. So here we have got an edge of the base of the hexagonal pyramid. It happens to be parallel to the vertical plane. Now this hexagonal pyramid has been drilled completely through and through with a circular hole of diameter 30 mm. So here we can check at a height of 25 mm from the base alongside the axis, we have obtained the center of this hole, which is going to have radius is equal to 15 mm or diameter is equal to 30 mm. Now this hole has been drilled in the hexagonal pyramid in such a way that the axis of the hole, it happens to be perpendicular to the vertical plane over here. So with this information, we are required to obtain the development of the lateral surface of the truncated pyramid over here. So now let us proceed with the construction of top view and the front view orthographic projections of this hexagonal pyramid. Now as the observer is going to view this hexagonal pyramid from the top, so we are going to obtain hexagonal projections onto the horizontal plane in the top view projections over here. So we know that the edge length happens to be 30 mm for this hexagonal construction, and we have marked all the 6 points of the base of this hexagonal pyramid into the top view projections over here. So the points A, B, C, D, E and F, they have been appropriately located into the top view projections over here. Now we need to evaluate the axis of this hexagonal pyramid. So we need to join the diagonals AD, BE and CF into the top view projections over here. So wherever these three diagonals, they are going to intersect with each other, we are going to obtain this point of intersection as the location of the axis point O and O1 into the top view projection. So point O, it corresponds to the apex point onto the axis, whereas point O1, it refers to the axis point which is lying onto the base of this hexagonal pyramid. So having obtained the top view projections of this hexagonal pyramid, now let us obtain the front view projections of this hexagonal pyramid. So the point A of the base will be projected as point A dash onto the XY reference line. Points B and F of the base, they are going to coincide with each other and they will be projected as points B dash and F dash onto the XY reference line. Similarly, the points C and E, they will be coinciding with each other in the front view projections and they will be projected as C dash and E dash onto the XY reference line. Similarly, the projection corresponding to the point D onto the XY reference line will be appearing as point D dash into the front view elevation projection view over here. So now we have obtained the axis O and O1. Now from the axis point of the top view, we have drawn the axis and projected it into the elevation projection view over here. So we know that the height of the axis of this hexagonal pyramid happens to be 75 mm. So the moment we mark this axis height of 75 mm into the elevation projection view, the apex point O dash will be appropriately located onto the axis over here. Now we can join this apex point O dash with all the base points corresponding to this hexagonal pyramid. So the slant generators O dash A dash, O dash B dash, O dash C dash, O dash D dash, O dash E dash and O dash F dash, they have been located into the front view elevation projection view over here. And the access point O1 dash corresponding to the base we have also located over here. So here one thing we need to understand, that all the slant generators OA, OB, OC, OD, OE and OF in the top view projections, they will be visible to the observer as the observer is going to look at this hexagonal pyramid from the top. Now we have been provided with the information that a circular hole of 30 millimeter diameter, it has been drilled through this pyramid such that the axis of the hole happens to be perpendicular to the vertical plane, and the axis of the hole, it intersects with axis of the pyramid at a height of 25 millimeter above its base over here. So here we have got the axis corresponding to this hexagonal pyramid O dash O1 dash. Now once we measure this distance 25 millimeter above the base over here, so now we are able to obtain the point of the center of the circular hole over here. Now we can check the diameter of this hole. It happens to be 30 millimeter. So now we can find this is a sectional cutting plane having diameter is equal to 30 millimeter, which is going to intersect with different slant edges of this particular hexagonal pyramid. Upon the intersection of this circular sectional plane with the hexagonal pyramid, now we observe that this is the remaining portion of the hexagonal pyramid which has been left after the cutting of this hexagonal pyramid by this hole which has been drilled perpendicular to the vertical plane over here. Now we can find that there are 8 points of intersection which we have obtained into the front view projections over here. So we can check the 2 points 2 dash and 8 dash, they have been obtained onto the slant edges O dash, B dash and O dash F dash. Similarly, the points of intersection 6 dash and 4 dash, they have been obtained by virtue of intersection of the circular sectional plane with the slant edges O dash C dash and O dash E dash over here. These are the 4 slant edges which have been intersected by the circular sectional plane over here. Now we can see that there is another point of intersection, that is point 1 dash over here. Now once we mark this diagonal of this particular hole having diameter 30 millimeter, so this diagonal will be 1 dash 5 dash. So now we are going to draw an additional generator starting from point O dash, so that this generator should be tangent to the point 1 dash over here, and once we extend this generator, it should be intersecting with the base between the points A dash B dash and A dash F dash over here. So the 2 points of intersection which we are going to obtain onto the base, they will be P dash and P1 dash over here. Now if we bring a perpendicular projector from these 2 points P dash and P1 dash, so we observe that this vertical projector, it is going to intersect with these 2 base edges of the hexagonal pyramid over here. It will be intersecting with the base edge AB. It will be intersecting with the base edge FA over here. So onto the front side, we will be assuming that point P will be obtained, and onto the rear side between the points F and A, the point P1 will be obtained over here. So this way we have been able to obtain 2 points of intersection over here onto the generators O dash P dash and O dash P1 dash over here. Similarly, from the point O dash of the apex, now we are going to draw another artificial generator, additional generator, in such a way that this generator drawn through the point O dash this should be tangent to the point phi dash of the circle over here, which is the diameter point of this particular circular hole. And then once it passes through the point phi dash, now it is going to intersect with the base of this hexagonal pyramid between the edges C dash D dash and D dash E dash over here. That is, between the edge CD, one point will be available. Between the edge DE, another point of intersection will be available. So now we are going to label these points as point R dash and R1 dash over here. Now from R dash and R1 dash, if we draw the vertical projectors onto these two edges of the base CD and DE over here, now we will see that onto the front side we are going to obtain the point R into the top view projection. Similarly, onto the edge DE we are going to obtain the point R1 into the top view projections over here. Similarly, we have another 2 points 3 dash and 7 dash over here into the front view projection. So these 2 points of intersections 3 dash and 7 dash we can obtain once again if we draw 2 more artificial generators over here, starting from the point O dash into the base of this particular hexagonal pyramid, such a way that we will have, we can check this slant generator over here OQ1 and OQ lying onto the base edges BC and EF over here also. So now these 2 points of intersection of the circular sectional plane with the hexagonal pyramid, they can be obtained once we are going to draw 2 more artificial generators in such a way that once we join O dash with Q dash and Q1 dash over here, now corresponding to these 2 points Q dash and Q1 dash, if we bring the vertical projectors over here into the top view projections, so we find that point Q happens to lie onto this base edge BC, which is lying onto the front side, whereas point Q1, it happens to lie onto the base edge EF, which is lying on the rear side of the solid. So we are going to assume that this slant edge will be lying onto this triangular face OEF over here. Similarly, OQ slant generator, this will be obtained onto this slant surface OBC, which is again an inclined surface over here. So this way 2 points which are symmetrically obtained diametrically, so they will be obtained onto the generators OQ and OQ1. So now you can check 4 points of intersections, they were available using the 4 slant generators which are already available over here. Now additional points we have been able to obtain by introducing additional generators over here. So this way we have got 8 points corresponding to this hole into the front face of this particular hexagonal pyramid and the rear face of this hexagonal pyramid. So 8 points of intersection, they will be available into the front face. 8 points of intersection, they will be available into the rear face of this hexagonal pyramid over here. Now we know that since the apparent lengths of the top view slant edges OA and OD, they happen to be parallel to the vertical plane, so the slant edges O dash A dash and O dash D dash in the front view projections, they represent true length of the slant edge of this hexagonal pyramid. Now with O as center, OA as radius equal to O dash A dash or O dash D dash, we are going to draw one arc with the radius equal to true length of the slant edge over here. Now one true length we have already obtained regarding the slant edge. Now we have also got true length of the edge of the base as 30 millimeter. So from point A, we are going to mark 6 arcs so that the 6 corners of the base we are able to locate. So A to B it will be 30 millimeter. BC will be 30 millimeter. CD is 30 millimeter. D arc we have drawn equal to radius 30 millimeter. EF and FA. So the 6 arcs we have drawn so that we can obtain 6 edges of the base over here. So having obtained all the base points into the development view, now we can join all the slant edges over here. And then we can join the corner points so that the base edges we have appropriately obtained into the development surface view. So now let us plot the different points P, Q, R, P1, Q1 and R1 which we have obtained corresponding to the additional generators which we have obtained onto the base edges over here. So we know that point P, it lies at this distance alongside the edge AB into the top view projections over here. So since this edge length AB is true length, so this distance, once we measure distance between A and P and mark this distance over here into the development surface view. So now the location of the point P can be identified over here. Now we can join OP into the development surface view over here. Similarly, point P1 we can identify it is located at this distance from point F or this distance from point A. So either way around, between points F and A, if we measure this distance, so we'll be able to locate point P1 in the development surface view over here. And now having located point P1, now we can join OP1 into the development surface area over here. Now the next point available is point Q. So we know that point Q happens to lie on the front side on the midpoint of the edge BC over here. So on the midpoint of the edge BC into the developed view, we have marked the midpoint over here. Now point Q has been located. Now we can join this generator OQ into the development surface area over here. Similarly, point Q1, it happens to lie alongside the edge EF at the midpoint over here. So between the point EF, we can mark the midpoint as Q1 point over here. Now having obtained the midpoint of EF, now we can join the projector line OQ1 over here. Next points, they are available with us, they are R and R1. So we know that point R, it happens to lie between these two corners C and D onto this edge CD. So onto the edge CD, we know the distance of point R from D. So we'll mark the same distance of R from D. So this point will be located into the development view over here. And having located point R, now we can join OR generator over here. And the last point which is available over here, it is R1. So R1 point, we have observed that it is going to lie between the base points D and D alongside the edge DE. So we'll measure this distance from point D, mark the point R1 into the development surface area over here. So mark same distance from point D. So once we locate point R1, now we can join this slant generator OR1 into the development surface view over here. Now all the generators corresponding to various points of intersection, they have been marked into the development surface area over here. Now we know that all these points of intersection 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash, they happen to lie onto the slant generators which happen to be apparent length projections into the front view projections over here. So here we have got O dash, P dash, O dash, P1 dash, O dash, B dash, O dash, F dash, O dash, Q dash, O dash, Q1 dash, O dash, C dash, O dash, E dash, O dash, R dash and O dash, R1 dash. All these slant generators, they happen to be apparent length slant generators over here. Now whatever distances we will be obtaining, O dash 1 dash, O dash 2 dash, O dash 3 dash, O dash 4 dash, O dash 5 dash, O dash 6 dash, O dash 7 dash and O dash 8 dash. All these radii will be the apparent length radii Now we have to mark over here onto the development view true length of all of these radii is corresponding to the different points of intersection. So how these true length radii we can obtain? We need to transfer all of these 8 points of intersection onto the true length. Only then the true length of these radii we will be able to obtain over here. So point 3 dash, if we extend it onto the true length over here, so this radius O-31 will represent the true length of the radius corresponding to the point of intersection 3 over here. Similarly, points 2 and 4 if they are projected onto this true length over here, that is O-D so this radius O-21 and O-41 this will represent true length of the radii corresponding to the points of intersection 2 and 4 Similarly, corresponding to points 1 and 5 points 1 and 5 they have been obtained over here. So this radius we are going to use instead of O-1 and O-5 Similarly, corresponding to the points 6 and 8 if we draw a horizontal projector line extended up to the true length slant edge over here, now this point of intersection of this horizontal projector with the true length will provide us with the radii O-61 O-81 over here into the true length projections over here. Similarly, the last point 7 again it is appearing onto the apparent length slant generator. So if we draw a horizontal projector line up to this point originating from point 7 so this radius it will be corresponding to point 7 and it will be labeled as O-71 so this will be the true length of the radius corresponding to the point of intersection 7 over here. Now all the true length of the radii now we are going to mark into the development surface view over here. So let us start from point 1. So point 1 happens to lie onto the generators O-P and O-P1 so here we have two generators OP and OP1 so we'll measure the radius equal to O-11 this is O-11 we can check O-11 happens to be this radius so this radius we will measure and mark it over here. This is the true length radius. We have marked it onto OP and OP1 over here. So 1 point has been obtained into the developed surface view over here. Now the next point available over here is 2 Now we know that the point of intersection 2 happens to lie onto the slant generators O-B and O-F over here. So 2 point we can mark onto O-B and O-F. So onto OB and OF over here. This is OF. This is OB. We can't mark this distance O-2. Which distance we have to mark? True length distance. So which is this distance? This is equal to this point. So O-21 distance we are going to mark. So this distance we have marked it over here and marked it onto OF. So these 2 points 2-1 have been obtained onto OB and OF respectively over here. Next point available with us is 3 So now this radius we have got O-3 onto the slant generators O-Q and O-Q1 That is, here we have OQ, here we have OQ1 over here. So now corresponding to point 3 this is the true length radius O-31 So once we measure this radius O-31 so after measurement of this radius, now onto OQ, same radius O31 has been marked onto OQ1. Again the radius O31 has been marked. So the third point has been obtained on the front side as well as onto the rear side projection of this hole over here. Now the fourth point of intersection is 4 The point 4 happens to lie onto the slant generators O-C and O-E over here. That is onto OC and onto OE. Now we will be measuring the radius of the true length corresponding to point 4 dash. This will be O dash 41 dash. This is 41 dash onto the true length. So we'll measure the radius O dash 41 dash. Now mark this radius O41 onto OC as well as onto OE over here. So the 2 points, one in the front face, another one in the rear face corresponding to the hole has been obtained. Next point of intersection is 5 dash. So 5 dash point happens to lie onto the slant generator O dash R dash and O dash R1 dash. So here we have got OR, here we have got OR1 over here. So now corresponding to point 5 dash, so true length of the distance will be O dash 51 dash over here. So we'll measure the distance O dash 51 dash, mark it onto OR and OR1. So the points 5, 1 will be obtained, one in the front face, one in the rear face corresponding to this hole over here. Next point of intersection happens to be point 6 over here. This is point 6. Now again point 6 happens to lie onto slant generators O dash C dash and O dash E dash over here. So what will be that radius distance? O dash 61 dash. This is the true length of the radius O dash 6 dash. So true length radius is O dash 61 dash. So onto OC we mark the same distance, onto OE we mark the same distance. So we obtain the point 6, 1, one in the front face, one in the rear face of this particular hole. Next point happens to be point 7. Now point 7 lies onto the slant generators O dash Q dash and O dash Q1 dash. So now the true length of this point 7 is O dash 71 dash. So onto the generators O dash Q dash and O dash Q1 dash. So this is OQ, this is OQ1 over here. So we'll mark the same distance of point 71. So 71 point is obtained onto OQ and onto OQ1 over here. And the last point of intersection happens to be point 8. It is this point. So from point 8 dash, now we can check 8 dash point lies onto slant generators O dash B dash and O dash F dash. So onto OB and onto OF over here. This is OF. Onto these two generators, now we are going to measure the true length corresponding to point 8 dash. This happens to be O dash 81 dash. This is 81 dash. O dash 81 dash distance we are going to measure. So onto OB, again we mark this distance. We obtain the point 8 dash. Onto OF, this is OF. We mark the same distance. So again point 81 has been obtained, one in the front face and one corresponding to the rear face. So now the development of the circular hole in the front face has been obtained. The development of the circular hole onto the rear face has also been obtained. So once we join these 8 points corresponding to the front face, so this is the development of the circular hole which has been obtained. Once we obtain another 8 points over here corresponding to the rear face, development of the circular hole projection into the rear face has been obtained. And now we can join the slant edges which have not been cut by this circular cutting plane over here. Now we can check the slant generators OA and OD. They have not been cut by this cutting plane. So we have not obtained any point of intersections with slant generators either OA or OD into the lateral surface development view over here. Now we can join the base edges also over here because the base edges, they have not been intersected by the cutting plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure to obtain the front view projections, the top view projections and the development of lateral surface of the truncated hexagonal pyramid in such a way that this hexagonal pyramid has been intersected by a circular sectional plane having diameter, it is equal to 30 millimeter, such that the axis of this hole happens to be perpendicular to the VP and the center of this hole, it is going to lie onto the axis of this hexagonal pyramid at a distance of 25 millimeter above the base of this hexagonal pyramid. So we are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.